quadrilateral, we should recognize quadrilateral meaning four sides. Yep. So definition of quadrilateral, just a four-sided polygon. Okay, so again, we're going to learn about parallelograms, rectangles, rhombi, that's just the plural for rhombus, squares, and trapezoids. Okay, so let's look at a parallelogram. Have we learned about parallelograms in the past? A little bit? Maybe?
It's also like base times height.
It is base times height. The area is base times height. For just the definition, if we think about the first part of the word, parallel, right? So both pairs, so it's a quadrilateral with both pairs of opposite sides are parallel. So these two sides are parallel, these two sides are parallel, and we use a nice little symbol just like with triangles, and we put a little parallelogram in front so you don't have to write out the word parallelogram each time. Good. All right, let's go right into the theorems. So we're not going to have names for these theorems. Instead, it's basically, if you have a parallelogram, the arrow means implies. So if you have a parallelogram, we know opposite sides are congruent. Okay, so that means these two sides are congruent and these two sides are congruent. But we don't necessarily know if all four are the same. All right, if we have a parallelogram, opposite angles are congruent. Where would opposite angles go? That one would go with the one in the top right. Good. And this one would match with this one. Okay. All right, next one. Consecutive angles are supplementary. What's that mean?
Bigger. I meant bigger than 90 or above.
Well, what's supplementary mean? They have to add up to 180. So let's say this is, I don't know, let's say that's 130 degrees.
50.
This has to be 50. And then this one also has to be 50. And then obviously this one has to be 130 because these also have to be supplementary. Good. Okay, if you have one right angle, then you have automatically four right angles in there. How do we know that? Well, think about the two previous theorems. If this is 90, this has to be 90. And also, opposite angles have to be congruent, right? So if you have a right angle, automatically the other three are all 90 degrees as well. Good? Make sense? Okay, we have two more. The next one has to do with the diagonals, and they are going to bisect each other. What does bisect mean? Cut in half. So I'm going to draw this and this. So that makes these two segments congruent and these two segments congruent. Are all four segments congruent to each other? Not necessarily. Could they be? They could. But if you see this one, the parallelogram is kind of stretched out. So obviously this diagonal is bigger than the other one. The last one, if you have a diagonal, it's going to separate it into two congruent triangles. So let's give that, let's say A, B, C, D. So how would we know that they are congruent?
Oh, triangle ABC equals triangle CDA.
Triangle ABC is congruent to triangle CDA. How do we know that if it's a parallelogram? Well, could we use all the previous theorems, right? So like opposite sides are congruent and reflexive. So we could do a quick, easy proof showing these two triangles are congruent by side, 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 right? All those other theorems that we did previously with triangles are still going to be true within a parallelogram. Also, you could do parallel lines, and then you could do like alternate interior angles. That would also work.
Oh.
Yay! Come on, Sophia. Yay, we're going to do a couple proofs. So here we're going to do 2 proofs in one. We want to prove if there's a parallelogram, we want to prove the first theorem. We want to prove opposite sides are congruent and opposite angles are congruent. Now, the only thing that we can start with is the definition. So if we have a parallelogram, what can we say? So if I know I have parallelogram ABCD,
The
opposite sides are, well, that's what we're trying to prove. Parallel. So I can say AB is parallel to DC, and I can say AD is parallel to BC. And that is our definition of a parallelogram. Don't worry if your parallelogram doesn't look perfect. As long as it has 4 sides, I will know that it means parallelogram. Okay? Okay. So, I'm trying to get these 2 sides congruent, these 2 sides congruent, and I'm going to try to get angle A is congruent to angle C. Adira? We're going to prove the triangles are congruent. So, without using that last theorem. So, in other words, we're just going to go based on this to prove these 2 theorems. So, don't jump ahead to... Okay, well, if we have parallel lines, what kind of angles do we have congruent?
AD.
Alternate interiors. So, I know these 2 angles are congruent. So, that's going to be angle ADB congruent to DBC.
Wait, are there any proofs in the quiz?
There could be.
No, the quiz, no, the test.
Test, yes, for sure.
What's the quiz?
I don't know. I don't remember. Okay. So this is alternate interior angles theorem. Right? And then we have another pair of alternate interior angles here and here. So let's write those right underneath. So angle, we could go with what? ABD? And angle BDC, because it's the same reason. Okay, so now what do we have? We have 2 pairs of congruent angles. What's the hopefully obvious next step? DB is congruent to DB. And this reason is reflexive. Okay, do we have enough information to say the triangles are congruent? Yes. What would be the reason? Angle, side angle. Now remember, it doesn't matter which way we say the first triangle. What order we want to put the first one in? ABD, that's fine. And then the next one, if it starts with A, we have to start with C. DB, good. And we said, ladies, angle, side angle. right? Because we have the two angles and the included side. All right, what now? Last step. Now that the
CPCTC.
good. So now that we know the two triangles are congruent, now the corresponding parts are congruent. So I can say my proof statement. So AB congruent to CD. I can say AD congruent to BC. And angle A is congruent to angle C because all of those have the same reason. CPCTC. Good. Okay, now that we proved those two theorems, we can use them on the next proof. Okay, so we have parallelogram ABCD. We could say AB. So we have a couple options now. Let's take a look. What am I trying to prove? I want to try to get EA or AE congruent to EC and VE congruent to ED. So this time, if I can get these two triangles on the two sides congruent or the top and the bottom triangles, I can use CPCTC then. Okay. Yeah, which do we want to do the top and the bottom one or the two sides? The sides? It doesn't matter.
I thought that's already a theorem. Yeah, they bisect each other.
Yes, but remember we're trying to prove the theorem. So we can't use the theorem to prove the theorem because then all of our proofs would only be 2 steps. That is a problem. I mean, I guess if you did that on a test, I could give you 1 point for the given. That would be about it. So if it was a 10-point proof, I'd be generous. I'd give you a point. Right? Okay. So, but we can use the 2 previous theorems, or what else? Well, I could do these 2 sides are parallel. Okay, so I have AD is parallel to BC. That's definition of a parallelogram. Okay, now. No, you could do that too. Oh, scooch over one. Shelby's here. Right. Oh, yeah. Whichever. Oh, it doesn't matter. Ryan, scooch up a little so she can. Okay. Okay, let's finish this proof. What do we want to do next? Any ideas? No. Alternate interior angles. So I can actually do that angle and these 2 angles. Right? Do you agree? These are alternate interior angles. These are also alternate interior angles. So I'm going to say angle DAE. So here DAE is congruent to ECB. Again, we just said those are alternate interior angles. And then how would we name these 2 angles? What do you think? ADE? And so ADE has to be congruent to this one. Yeah. CBE is good. Okay, so I have two pairs of angles. Now I need, we could do vertical angles, but we don't really need it. We already have two pairs of angles, but we need to have a pair of congruent sides. What else do we know? What did we just prove in the last one? If you have a parallelogram? Good. So AD, good. You could do vertical. We just don't need to use it because we already have two angles. Bless you. Okay, so now the way we're going to write this, a parallelogram, and then the arrow, so that implies opposite. What are those? Those are sides, right? So sides are running out of room. Congruent. Okay, do I have enough information to say these two triangles are congruent? What's the reason? Angle, side, angle. Okay, so I'll go with triangle ADE. Congruent to? Yeah, the last one is going to be CBE. We already said angle, side, angle. And now that these two triangles are congruent, is AE congruent to EC? Yes. And BE and ED are congruent. And we know that because CP, CTC. Okay, questions? Good? Yeah? Any questions? Okay. Last proof for the notes. We haven't done all this writing in a while, have we? Yeah, this is for the notes. This is the last. Oh, is there another one? Oh, yeah, there is one last one. Sorry, I thought it was the last one. Oh, yay. I know, I thought it was the last one, and somebody looked ahead. Okay. Okay, so let's see. What do we need to do here? Okay, so X, Y, R, Z. So that is a parallelogram. Do we see it? Okay, so that's a parallelogram. And what else are we given? We know WZ is congruent to WS. So I'm just going to kind of, those two sides. What does that make the big triangle? Isosceles. Good. So we can say if these two sides are congruent, angle Z is congruent to angle S. Do you remember that? These two are congruent. Right? Right. So angle Z. Now I only need one letter for these because there's only one angle at those particular points. So if you want to use three letters, you can. Does anybody remember the reason? Isosceles triangle theorem. It's okay. If you wrote isosceles theorem, I'd give you credit because if you're talking about something isosceles, it's automatically referring to a triangle. Okay. All right, now what are we trying to prove? We want to get angle XYR congruent to angle S. What do you think? What do you think, Eli?
Angle Z is congruent to angle XYR.
Angle Z. Nope. because it's a parallelogram, we know opposite angles are congruent. So we have these two congruent. We have these two congruent. So now transitive property will get us these two to be congruent. You see how they're both congruent to angle Z? So first we need to give this a reason.
Parallelogram.
What does what kind of angles are these? They're opposite angles.
But why would it not be?
What's the matter? What's wrong? These two are opposite angles. And see, now that angle Z is congruent to both of these, we can say XY are congruent to angle Z.
No S.
Sorry. Thank you.
Yes.
Transitive property.
That's so good.
All right. Okay, so here we have a parallelogram. So we just want to fill in the blank, which are each of these congruent or supplementary to. So SV.
VQ.
Good, VQ. Okay, we need a reason. Okay, so from that first page of the notes, that had all those theorems. What's the reason? Diagonals bisect each other. Good. And yes, I'll try to remember for Monday, I'll print out all the new theorems. Okay, what about the next one? So we have angle SRQ has to be congruent to QST or STQ, it doesn't matter. So these two angles. All right, and what are those? Opposite angles, good. So opposite angles are congruent. All right, next one, what do we know? We know QT. QT? Wait, QT is RS or SR. Oops. I'm getting the hang of this. So parallel, well, because what are these? What kind of sides are those? They're parallel, but they're also opposite. They're opposite. So we're going to say opposite sides are congruent. Because they're the sides of the parallelogram. Just like if I said RQ would be opposite to ST. Okay, then we have triangle SRQ would be congruent to what other triangle? Q. SRQ. So SRQ. I feel like I'm hearing a bunch of different, what did we do? QTS. And that is, if you have a parallelogram, we'll just say the two triangles are congruent. Don't worry about it. It's basically the two triangles created by a diagonal. We'll make two congruent triangles, but you can just abbreviate it that way. And lastly, angle TSR. TSR is supplementary to, we actually have two options. Both are right. Okay, so you can say this angle here or this angle here. So just pick one. So we'll say RQT. Is that the one you said? And the reason is these are consecutive angles, are supplementary. Good. Any questions? Okay, Sophia, we're almost done. Come on. We got this. Okay, so next one, these we're just going to be solving. These. So if we have parallelogram JKLM, yeah, so what do we, so let's take a look. What do we know? We know opposite sides are congruent. So that means 3A is 21. So why don't we find the value of the variables first? So A equals 7. And we also know what else? We know 2B plus 3 is 45. So let's see. What do we get for B? B is 21. Wait, 21. Okay, what else do we know? Let's look at the angles inside here. So if this is 30 and this is 70, that adds up to 100. But also we knew these would be alternate interior angles. So this one up here would be 30. And this would be 70. Okay.
It's 78.
Is that better?
Yeah, much better.
Okay, thanks. All right, let's see if we can fill in some of the blanks here. So measure of angle MJK. MJK has to be 100. All right, JML. Right here, J has to be 80. Because if this is 100, this one has to be 80 degrees because consecutive angles have to be supplementary. Okay, how about JKL? Same thing, right? 80 degrees. All right, angle KJL. KJL, 30. We already labeled it. And we already found A and B over here, so we'll put A is 7 and B is 21. Yeah, these are the easier. Most of the homework will be just setting things equal like this or supplementary. Okay, we have two parallelograms in this one. VZRQ and WQST. So maybe I'll kind of trace over it so we can see. So VZRQ, so that's going to be here. And the other one is WQST. So these two parallelograms are like overlapping each other. And what do we want to prove? Z is congruent to angle T. What do you think?
Q is equal to Z.
Yep.
Q is equal to Z.
Q is congruent to Z. And Q is congruent to T. Sophia. I meant Z. What's the reason? Parallelogram implies good are congruent. And then we're done, right? We just have one step. Well, transitive, right? Angle Z is congruent to angle T by, this is the shortest proof, transitive property. I mean, you could have done it in more steps, but